Today I will be going over how GPUs schedule their work through data parallelism through a more software/hardware interaction perspective. Before we get into the details of the hardware, we need to understand the software perspective. So when you launch a kernel on a GPU device, that kernel gets broken down into a grid and then blocks and then ultimately threads that actually run on the GPU. These threads are grouped into what are called warps in groups of 32 threads. So when we look into how the scheduling kind of works, it follows a SIMT paradigm. It means single instruction, multiple thread. It's very similar to a SIMD paradigm, where we have a single instruction, multiple data. What you need to know is that these are both forms of what we call data parallelism. This is kind of how vector ops are done in the CPU, and that's the whole paradigm behind GPUs. You're able to do this massive data parallelism to achieve a very high throughput. And so when these warps are actually scheduled onto a warp scheduler, the warp scheduler swaps warps in and out depending on which warps are ready. The warp scheduler doesn't wait around for data stalls for one warp. It will schedule what is ready to be scheduled. It'll swap things out. It'll do what needs to be done to keep the functional units occupied and actually doing things. And that's kind of how the software and the hardware interact with each other to create this massive data parallelism. And what you can notice about GPU programming specifically compared to your traditional CPU programming, there's a lot more that the programmer has to worry about when writing GPU kernel code. You're essentially, as the programmer, the scheduler. That's what's important to understand.